A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth on December 17th. Comet, asteroid, or something else?
James Webb Space Telescope just picked up something no one expected. A chemical signal from 3I Atlas that does not match any known comet profile.
Using all the assets we have on Earth and in space to get as much data as possible about this mysterious object.
The data shows a high concentration of frozen carbon dioxide and prebiotic molecules that shouldn't survive that kind of heat. NASA has released fragments of the data, but not the whole picture.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
This may be the most important object to enter our solar system in years. And if we lose it, we may lose our only chance to understand what it really is. The intersection. The James Webb Space Telescope was not launched to study 3I Atlas. It was designed to look into the deep past of the universe and the afterglow of the Big Bang. But when an interstellar comet crosses our doorstep, science pivots, and James Webb's infrared instruments became our most powerful tool for understanding this alien traveler. While 3I Atlas was behind the sun from Earth's point of view, ground-based telescopes were completely blind. The glare made it impossible to see. But the James Webb Space Telescope, located far from Earth at the second Lagrange point, had a clear view. It was one of the only instruments in the solar system that could keep watching, and it did. What it picked was something extremely valuable, a chemical signature, fingerprint of where this thing came from and what it might be. Webb's spectrometers picked up extremely high levels of frozen carbon dioxide. The ratio of carbon dioxide ice to water ice was one of the highest ever recorded in any known comet, even higher than what we saw in the previous interstellar visitor, 2I Borisov. This matters because it tells us about the place where this object was born. In our own solar system, water ice is common in comets. Carbon dioxide is usually found in smaller amounts. But 3I Atlas reverses that pattern. Its makeup suggests it formed in a region much colder, much farther from its parent star, or under very different chemical conditions altogether. This is a preserved sample of an alien environment, one that we cannot visit. And this is just the beginning. The spectroscopy data revealed that the comet's coma was unusually stable. It did not fluctuate the way typical cometary comas do. This suggests that the source of its material loss is unusually steady, or possibly controlled by a mechanism we do not yet understand. That is not to say artificial, but it is certainly unusual. The significance of this cannot be overstated. Webb's instruments do not just take pretty pictures. They break down the composition of light. They show us what elements and molecules are present, and when those readings do not match what we expect, scientists notice. So far, the public has only seen part of this data. The full dataset, according to the Space Telescope Science Institute, is still under review. That review process is rigorous. It involves calibration, error checking, and confirmation from multiple teams. But the early findings have already raised eyebrows. We are seeing something that formed in another solar system. We are reading its chemical DNA, and it is not matching the family tree we know. The reason this is causing so much stir is because it happened during a window of time when no other instruments were watching, and what it caught might not happen again in our lifetimes. What happened next, once scientists started comparing those readings to known comets, made everything far stranger. Anomalies beyond the norm. There are comets. Then there is 3I Atlas. Every time scientists gather more data, the same pattern emerges. The deeper they look, the harder it is to explain the behavior of this object using the normal models we've built over centuries of comet observation. Let's start with the heartbeat. 3I Atlas pulses. Its light brightens and dims every 16.16 hours with incredible regularity. This is not random flickering caused by sunlight bouncing off a jagged surface. This is rhythmic and measurable. Multiple independent observatories, including the European Southern Observatory and amateur astronomers using stacked photometric data, have tracked this cycle. Every 16.16 hours, it flashes. Scientists call it a rotational light curve. That is a known phenomenon. Many comets spin, and as they do, they reflect more or less light depending on which face is visible. But not like this. Most comets wobble or tumble. This one is smooth and exact like a ticking second hand. That precision has set off alarm bells in the scientific community, because such regularity is rare in natural objects. When it does appear, it usually comes from something artificial. Even stranger, the pulse appears to be tied to gas jets, powerful eruptions of volatile material shooting out from beneath the surface. But the jets themselves are not where they should be. On most comets, outgassing is strongest when the object is closest to the sun. The heat activates the surface ice, creating dramatic bursts of vapor and dust. But 3I Atlas began strong outgassing well before perihelion, when it was still extremely cold. And it has continued long after. The timing does not make sense. It is not just the timing, it is the content. The comet's coma includes surprisingly high levels of methanol and hydrogen cyanide. These molecules are considered prebiotic. They are the same kinds of chemicals scientists believe played a role in the early development of life on Earth. Hydrogen cyanide is a molecule that can interact with other elements to form amino acids, which are the building blocks of life. This is not just trace amounts either. The methanol concentration is several times higher than what we typically find in comets from our own solar system. It is a rich chemical stew, one that should not exist in that proportion unless it formed in a very specific kind of environment, one very different from anything near our sun. Some astronomers argue that this supports the idea that star systems throughout the galaxy are chemically diverse, that comets from other systems will naturally look strange to us. But others are less sure, because if these anomalies stopped at chemistry, they might be easy to explain away, but they don't. It is changing its velocity in ways that cannot be explained by gravity alone. This is called non-gravitational acceleration. And while it can happen to comets due to asymmetric outgassing, the force required here is not lining up with the observed outgassing. Add to that the strange rotational behavior. Unlike most comets, 3I Atlas is not slowing down. It should be. Jets of gas tend to push unevenly on the surface, gradually changing an object's spin rate. But this one stays locked at the same speed, almost like it is self-correcting. This combination of consistent thrust, stable spin, and irregular outgassing starts to look less like a comet and more like a mechanism, or at the very least, something that isn't behaving randomly. Each one of these findings on its own could be explained as an outlier, but taken together, they form a profile of something that refuses to behave like the comets we know. At some point, when every known explanation has been exhausted, the only thing left is to consider the possibility that we are looking at something engineered. Which brings us to the next question. If the data is this strange, if the behavior is this inconsistent, and if the implications are this massive, then why is no one at NASA saying more? Why are the official answers so calm when the raw data is anything but? NASA's silence isn't what it seems. NASA has not gone silent. It only feels like silence because the agency is not saying what the public wants to hear. People want explanations and confirmation of their suspicions or denial of their fears. But that is not how science works. And NASA knows it. Let's start with the facts. The official stance from NASA and the European Space Agency is very clear. They are labeling 3I Atlas as a comet. A highly unusual one, yes, but still a natural object, a product of astrophysical processes, shaped by the environment of its birth system and sculpted by its journey through interstellar space. They are not calling it artificial, and that decision has triggered a storm of speculation online. When the James Webb Space Telescope collects data, that data does not go directly to the public. It is processed, calibrated, and analyzed by teams of scientists. The instruments on board are some of the most sensitive ever created. A single miscalibration can lead to faulty conclusions, so every reading is checked, then double-checked, then reviewed by peer groups. It is a long, slow process. The second reason for their silence is more subtle. It has to do with language. When scientists talk about anomalies, they do not rush to conclusions. They avoid definitive statements until the evidence is overwhelming. They use phrases like "not yet understood," "requires further study," or "inconsistent with existing models." To the average person, that sounds like avoidance. But in the scientific world, it is how credibility is preserved. It is how knowledge builds. NASA has seen what happens when they speculate too early. Remember Oumuamua, the first interstellar object. When some researchers publicly raised the possibility that it might be artificial, the backlash was instant. The press ran wild, the public latched onto the alien theory, and NASA was forced to walk it back, even though the anomalies were real. That experience has shaped how they now talk about 3I Atlas. They are not going to fuel another media fire unless they have hard, peer-reviewed confirmation of something truly unprecedented. There are now more than a dozen anomalies associated with this object. That includes the stable heartbeat, the chemical outliers, the methanol spikes, the acceleration, and the unusual pre-perihelion outgassing. Yet none of these have been highlighted in any official press release. NASA has acknowledged some of the data, but they have not connected the dots. They are presenting it piecemeal, each finding treated as a separate curiosity. Several astrophysicists, both within and outside of the agency, have raised questions about how this case is being handled. Others say it is exactly what should happen. Right now, NASA has in its possession high-resolution, near-infrared spectroscopic data of an interstellar object showing signs we do not fully understand, and the world is watching. And NASA, by continuing to treat each one as an isolated feature, may be protecting its process, but it is losing control of the story, because outside that process, the narrative is moving fast. And it is moving toward a possibility that many experts once refused to consider. The plausible but uncomfortable theory. Science rarely likes to use the word artificial. That word implies intent. It crosses a threshold that most researchers are deeply uncomfortable with, because the moment you entertain the possibility of technology, the burden of proof becomes enormous. But when an object defies every known model, then what are we looking at? A small but growing group of researchers is no longer asking whether 3I Atlas is a comet.
But it means that 3I Atlas is scattering light in such a way that has never been seen before for any other comet or asteroid in our solar system.
They are asking whether it is only pretending to be one. At the center of this conversation is a simple, unsettling theory that this object, or something like it, may be a technological relic. Perhaps a derelict automated vessel that once served a function and has now fallen silent, drifting across the galaxy, collecting dust and ice as it moves from one system to another. This is, in fact, a possibility that has already been modeled. Astrophysicist Avi Loeb, former chair of Harvard's astronomy department, has been vocal about this idea for years. He argued that our first interstellar visitor, Oumuamua, could have been just such an object because it did not behave like anything else.
Oumuamua is probably a comet. The only problem is there wasn't any cometary tail.
Now, with 3I Atlas, we are seeing echoes of those same red flags. But this time, we have better tools. We have the James Webb Space Telescope. We have ground-based radio arrays. We have international coordination. And the anomalies are not subtle. If you take the raw facts and strip away the assumptions, here is what remains. The object's acceleration does not align with its measured outgassing. Its spin rate is stable, even when it should be changing. Its chemistry includes exotic ratios of carbon dioxide, methanol, and hydrogen cyanide. Its visual brightness pulses at an exact 16.16-hour interval. It began releasing gas before sunlight could have triggered that release. Together, they form a profile of something far stranger than a natural rock. They begin to resemble function. Imagine this scenario. A derelict probe, built by an alien civilization thousands or millions of years ago, has spent eons drifting through interstellar space.
Harvard professor Avi Loeb says aspects of these images, instead he argues, it could be alien technology.
Along the way, it collects a crust of dust and ice, just like any object exposed to the vacuum for long enough. It enters our solar system. As it nears the sun, the outer layer begins to sublimate. The sunlight heats it, the ice turns to gas. Jets of vapor erupt, mimicking the behavior of a comet. To most instruments, it looks exactly like what we expect, a frozen object heating up. But underneath the ice is something else, a structure. But it is shaped in a way that creates regular rotation. Maybe it once had internal gyroscopes. Maybe the orientation still holds. And maybe, just maybe, the steady pulse we see is the echo of that engineered form. In this scenario, the acceleration is not caused by natural jets of vapor. It is caused by controlled propulsion. Small thruster burns, now malfunctioning, or automatic corrections from a dying navigation system. The absence of visible thrust can be explained by the scale. A small gas ejection is invisible to even our best telescopes if it is directional, if it uses non-reactive compounds, or if it occurs in brief pulses. If 3I Atlas is natural, then we are witnessing an extraordinary example of interstellar diversity. A comet from another system that behaves in ways we have never seen before, because it comes from conditions we have never observed. But if it is not natural, then we are looking at something else entirely. Something that once served a purpose, even if we can no longer detect what that purpose was. Scientists are looking at the velocity of the ejected particles. That is the key. If the object is outgassing naturally, the particles should be moving at a few hundred meters per second. But if those jets are the result of a technological propulsion system, they will be moving at several thousand meters per second and in precise directions. That measurement is not easy to make. It requires ultra-fine resolution, it requires long observation windows, and it requires cooperation between telescopes across the planet and in space. But if it can be done, it will answer the question that no one wants to ask out loud. Because if 3I Atlas is not natural, it means we were never alone.
It's 1,000,000 times more massive than the previous two interstellar objects, Oumuamua and Borisov.
Not in theory, speculation, or in physical, measurable reality. And if it is natural, then the rules of what a comet can be just changed forever. Either answer will shift the foundation of astronomy, but we may not get another chance to find out, because 3I Atlas is already fading. The final light. 3I Atlas is leaving. Whatever it is, comet, artifact, anomaly, it is moving away from us at over 200,000 kilometers per hour. Its trajectory will take it beyond the range of our best instruments. The moment to study it is now. We are watching the last light from an interstellar visitor, and for the second time in just 6 years, humanity is unprepared to fully capture what it might be. With 3I Atlas, the James Webb Space Telescope, and predictive tracking models. And yet, the data we now hold is still incomplete. We have fragments of chemical signatures, strange light curves, odd acceleration logs, but no decisive measurement or final truth. This is a failure of planning. No space agency, no research institution, no global initiative has yet developed a rapid response interstellar object program. There is no standing protocol for redirecting all available telescopes, launching probes, or adjusting mission objectives to follow these once-in-a-generation events. These decisions still rely on committees, proposals, and approvals. By the time they get through the bureaucracy, the object is already on its way out. And once it is gone forever. 3I Atlas is passing through our solar system on a hyperbolic arc. That means it is escaping the sun's gravity entirely.
3I Atlas gets closer to the sun, it will be illuminated, it will get brighter, since it will reflect more sunlight.
In just a few more weeks, it will have faded below the detection threshold of most Earth-based instruments. Only space telescopes like Webb will be able to catch its final emissions. After that, it will become another anonymous speck in the dark. But even as it fades, the legacy of 3I Atlas is already forming. This object has pushed the scientific community to confront the limits of its own definitions. For decades, we assumed comets were frozen leftovers from the formation of our solar system. But interstellar objects are not playing by those rules. They are teaching us that our models are too narrow, that space is far more diverse than we imagined, that the chemistry of life, or the machinery of something else, may be spread across the stars in ways we have barely begun to understand. The detection of methanol and hydrogen cyanide in such abundance is a game changer. These are not exotic molecules. They are the raw materials that, under the right conditions, can lead to amino acids. And from there, to life. The idea that these building blocks are common, drifting between stars, riding on the backs of icy wanderers. This tells us that Earth may not be special in its chemistry, that life may be seeded more easily than we ever believed. And then there is the other possibility, that what we are seeing is not just chemistry, but engineering. That the anomalies, from the steady spin, the unexplained acceleration, to the unnatural timing of outgases, are not quirks, but rather fingerprints. If that is true, then 3I Atlas is the closest thing humanity has ever encountered to proof of another civilization. And we may never know for sure, because it is now vanishing quickly. Because all of this is happening in real time, and in silence because NASA is being too cautious. Some astronomers are already calling for changes. For the next chance. For the next anomaly that drifts into our gravitational well. 3I Atlas is not waiting. We may never answer that question with certainty. But here is what we do know. 3I Atlas came from somewhere else. It behaved in ways we do not fully understand, and now we may never find the real meaning behind it.